For years, you have been conditioned to believe that affordable means compromise. You expect smaller batteries, weaker motors, and interiors stripped to the bone. But strip away those expectations and look at Giga Texas. September 2025, 50,000-ton presses roaring to life, transformers the size of buildings rolling through the gates. While the rest of the world debates if a budget EV can ever feel premium, Elon Musk is not just arguing the point, he is demolishing it. This is a production line that does not just lower costs, it crushes the very barriers of complexity and scale. We are about to decode the innovation that is shattering every limit you thought existed. If you want to stand among the few who understand where automotive manufacturing is actually headed, not just where the marketing brochures say it is going, you need to hit that subscribe button. Lock in your advantage now and click the bell so you never miss the technical breakdowns that others pay consultants to understand. First, you have to ask, how does 100% American manufacturing actually make the Model 2 faster to build? You know, the bottleneck has always been the global supply chain. Even the new Model Y Juniper, launched at over $46,000, still relies on overseas shipments for a quarter of its battery and electronics. The Model 2 flips the script. It slashes imports to less than 2%, becoming the first Tesla built with almost everything sourced on home soil. The revolution starts in the battery pack. Imagine ditching the traditional lithium-ion headache. No more reliance on imported cobalt or nickel, no more waiting on shipments from China. These materials are not just expensive, they carry hidden costs. From trans-Pacific shipping fees to that stinging 25% tariff, every lithium battery you buy essentially comes with a global supply chain tax. But Tesla is pivoting to sodium-ion, and that changes the game entirely. Consider the resources right under your feet. Texas alone produces 10 million tons of salt every year. Tesla needs less than 0.1% of that supply to produce up to 16 million battery packs annually. The scarcity fear is gone. By cutting out 4 weeks of refining abroad and a month at sea, the time to produce a battery collapses from 6 months to just 1 or 2 weeks. The entire chain from processing to manufacturing happens right here. This proximity slashes costs with brutal efficiency. Sodium batteries cost nearly 70% less to manufacture than their lithium counterparts. While a standard lithium pack might set the cost back $7,500, a sodium pack rings in at just $1,500. That is $6,000 in direct savings for every single Model 2 money that stays in the ecosystem rather than vanishing into logistics. But, the real genius lies in how Tesla manipulates time. They're not just making batteries faster, they're parallelizing the entire world. Traditional automakers are stuck in a sequential relay race. Mine, ship, refine, assemble, wait. Tesla's vertical integration at Giga Texas runs everything at once. Salt extraction, electrochemical processing and assembly happen simultaneously on the same campus. It's not just an improvement in speed, it is a fundamental restructuring of manufacturing physics. So, let's compare that to the industry gold standard. Toyota's supply chain, for example, moves at a respectable 45-day inventory turn, but Tesla's Model 2 line is actually targeting just 8 days. That is not an incremental step forward, it's a 5.6 times acceleration in capital efficiency. Every single dollar invested cycles through production almost 6 times faster than the competition. In the manufacturing economics of 2026, velocity is, well, pretty much synonymous with profitability. And the revolution isn't just limited to batteries. Right now you're witnessing a complete severance from overseas electronics. Over at Giga Texas, chip production is moving in-house, and it's being supported by locally made control units from Texas Instruments. Chipsets that used to cost $2,000 to import now cost somewhere between $900 and $1,200. While traditional manufacturers are, forced to adapt general-purpose silicon, Tesla actually designs domain-specific circuits exclusively for the car. Motor control, battery management, autonomous driving, everything is architected from the ground up and manufactured at scale. This creates more than just cost savings, it actually unlocks pure performance. These custom chips process data 40% faster while consuming 30% less power than off-the-shelf equivalents. That efficiency practically gifts you range, adding up to 18 miles per charge just from smarter silicon. With imports dropping from 25% on the Model Y to barely 2% on the Model 2, you are looking at the first Tesla that is, effectively, 99% American-made. Here is where the macroeconomics, really hit your wallet. Domestic manufacturing does not just save Tesla capital, it actually saves you $10,000. It unlocks the full $7,500 tax credit and exemptions reserved for vehicles with at least 85% domestic components. So, Let's take that announced $25,000 price tag. Then, when you apply the incentives, the car could actually land in your driveway for, well, under $17,500. You're basically getting premium EV technology for less than the price of a base Toyota Corolla. If seeing premium tech at economy prices is exactly why you watch this channel, hey, make sure you are subscribed to Drivexa. We break down the value that others, might miss. Now tell us which breakthrough matters most to you. Comment 1 for sodium-ion batteries, or 2 for domestic chip production, or 3 for the complete vertical integration strategy. Now consider the structural integrity. How do you eliminate 5,600 potential failure points in a single stroke? It's a pretty big challenge, right? The strength of any electric vehicle really comes down to its frame. On the Model 2 line, the challenge is building a chassis that will not need fixing for 20 years and refuses to rust no matter the terrain. The answer lies in the casting technology that has every other automaker desperately playing catch-up. While Ford is just beginning to experiment with a 9,300-ton press, Elon Musk is already pulling the covers off 50,000-ton monsters. These are not just machines, they are industrial giants capable of casting the entire car in just 3 massive pieces: the front, the rear, and the floor. In one move, you are watching 90% of the welds vanish. A Model 3 relies on over 6,000 weld points to hold together, but on the Model 2, that number drops to just 400. That means thousands of potential cracks, breaks, and weak spots are simply gone. With fewer joints, the frame does not just hold together, it stays silent. When you hit a pothole at 40 miles per hour, the impact does not hunt for a weak link. It spreads evenly through a unified structure. Traditional frames are a jigsaw puzzle of 400 stamped parts where, honestly, microscopic errors stack up across hundreds of components. Tesla's megacastings eliminate this tolerance stacking entirely. You get a dimensional accuracy of plus or minus 0.0197 inches. It is 5 times more precise than anything welded by human or robot hands. The speed difference is almost unfair. BMW's best automated line takes 18 robots 96 seconds to weld a frame. Tesla's GigaPress casts the rear section in 90 seconds with a single machine. That is an 18-to-1 leap in capital efficiency. You are looking at 83 fewer robots, half the floor space, and drastically lower energy consumption. If you appreciate this level of engineering breakdown, make sure you have liked this video and subscribed. We track the efficiency numbers that define the future. But the innovation here, it goes all the way down to the molecular level. This isn't just your standard car aluminum, it's TX7A alloy featuring a nanocrystalline structure. And it doesn't just resist stress, it actually absorbs vibration through elastic deformation. It can handle millions of cycles from those rough gravel roads without showing any fatigue. And, unlike traditional alloys that just end up as low-grade scrap, TX7A actually retains its properties. But, the most critical leap is autonomous. FSD version 14 is baked directly into the Model 2, powered by the new AI5 chip. This silicon beast is, 8 times faster than its predecessor with 9 times the memory. It makes the car safer than you are. The data proves it. The average American crashes once every 1.13 million miles. FSD version 14 pushes that horizon to 1 in 10.77 million. If you're coming home tired after a long shift, or if your reaction times are not what they used to be, the stress just, evaporates. No hyperfocus, no panic, just a machine that sees everything you might miss. The insurance giants cannot ignore the math. Progressive and State Farm are already slashing premiums by 25% for drivers who trust the software on the highway. Why? Because the actuarial data is undeniable. In 2025, FSD active vehicles reported 78% fewer claims. By 2026, collision rates for the Model 2 are projected to plummet below 0.4 claims per 100 vehicles. Compare that to the standard 2.3 for traditional cars. This cheap car does not just drive itself, it pays for itself, putting $600 to $800 back in your pocket every